Is matter around us pure? Class 9 Science, Chapter 2, Part 1. Dear students, in this lesson, we will learn about what is meant by pure substances, then pure substances and mixtures and their types. We will also learn about true solutions and their properties, colloidal solutions and their properties, suspensions and their properties, and saturated solution and concentration of solution. Dear students, watch this picture carefully. Here we can see packet of pure ghee and packet of pure milk. What is meant by pure? Perhaps you may say that pure means no adulteration. But scientifically, pure means all the constituent particles of substance are same in their chemical nature. So, pure milk may not be scientifically pure because milk contains particles of fat, protein, vitamin. So, milk is scientifically not pure. Now, we will discuss more about pure substances. Classification of matter. In previous lesson, we learned about matter. Anything which has mass and which occupies space is matter. And on the basis of physical state, matter can be classified into three main types: solid, liquid, and gases. And on the basis of chemical composition, matter is classified into two main types. They are pure substances and mixtures. Pure substances are of two types: elements and compounds. And mixtures are of two types: the homogeneous mixtures and the heterogeneous mixtures. Pure substances and mixtures. Let us think about iron, copper, hydrogen, oxygen, water. All these are consisting of single type of substances, may be element or compound. So they are pure substances. Means a substance which consists of single type of substance, element or compound. Now think about seawater is having water, salt and other minerals. Soil having different particles. Then air having different gases. A mixture of sand and salt. A mixture of sugar and water. Salt in water. We see that they consist of two or more pure substances. So they are called mixtures. Mixture means a substance which consists of two or more pure substances. Now let us differentiate between pure substances and mixtures. Pure substances consist of single type of substance and mixture consists of two or more pure substances. Pure substance cannot be separated into other substances by physical method, but mixtures can be separated into its components by physical methods. Then pure substances has its own definite properties and mixture shows the properties of its components. Pure substances are further classified into element and compound. Element is a pure substance that consists of only one kind of atoms. Always remember, only one kind of atoms: carbon, hydrogen, nitrogen, cobalt, tin, lead, mercury, etc. Now, compound. Compound is also a pure substance like element, but it is made up of two or more than two elements mixed in fixed proportion by mass. So always remember, in compound, elements are present in fixed proportion by mass. The compound can be decomposed into its chemical constituents by chemical methods only. Example: water, carbon dioxide, ammonia, etc. Now watch this picture carefully. Here hydrogen is made up of two atoms of hydrogen and both the atoms are of same kind. Oxygen is made up of two atoms of oxygen and both are of same kind. Nitrogen is made up of two atoms of nitrogen, both are of same kind. And chlorine is made up of two atoms of chlorine, both are of same kind. So these are all elements made up of same kind of atoms. Now let us see nitrogen oxide. Nitrogen oxide is a compound made up of nitrogen and oxygen atoms. So both the atoms are of different types and mixed together in fixed proportion. In water, we can see that it is made up of two atoms of hydrogen and one atom of oxygen. Then nitrogen dioxide is made up of two nitrogen atoms and one oxygen atom. Carbon dioxide is made up of two oxygen atoms and one carbon atom. Here all are compounds as they are made up of two or more different kinds of atoms of elements mixed together in fixed proportion. In this video, we can see oxygen molecules. Each molecule is made up of two same kind of atoms of oxygen. In this video, we can see hydrogen molecules. Each molecule is made up of two hydrogen atoms of same kind. This video shows atoms of element gold. All atoms are of same kind. This video shows molecules of carbon dioxide. Each molecule of carbon dioxide is made up of one carbon atom and two oxygen atoms. So it is a compound. In this video, we can see methane molecule made up of one carbon and four hydrogen atoms. In this video, we can see air, a mixture of gases. Here we can see oxygen molecules, nitrogen molecules, hydrogen molecules, and carbon dioxide molecules. In this picture, it is clearly seen that elements are made up of only one kind of atoms. Compounds are made up of two or more kind of elements mixed together in fixed proportion. And mixture is made up of elements and compounds mixed in any proportion. Let us learn more about types of mixtures. Mixtures are of two types: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures has a uniform composition and heterogeneous mixture has non-uniform composition. Say for example, sugar in water, it shows uniform composition and the particles of mixtures are not visible by the naked eye. But a heterogeneous mixture of salt and sand, the particles are visible by the naked eye. Homogeneous mixtures cannot be separated by simple filtration methods. Heterogeneous mixtures can be separated by filtration. Homogeneous mixtures are stable and particles do not settle down. Heterogeneous mixtures are unstable and particles settle down. The path of beam of light is not visible in homogeneous mixture, but the path of beam of light is visible in heterogeneous mixture. Mixtures can be categorized into two groups: homogeneous and heterogeneous. For the homogeneous mixture, best example true solutions, and heterogeneous mixtures can be colloids or suspensions. True solution. A true solution is homogeneous mixture of two or more substances. A solution has solvent and solute as its components. The component in the larger amount is the solvent and the component in the lesser amount is the solute. For example, solution of salt in water. Here the salt is solute and water is solvent. Then solution of sugar in water. The sugar is solute and water is solvent. Now let us discuss properties of true solution. True solutions is a homogeneous mixture. Its particles cannot be seen by the naked eye. When we see the salt in water, we cannot see by naked eye only. The solute particles cannot be separated by filtration. We cannot separate the salt particles from the salt solution by simple filtration. The solute particle does not settle down and the solution is stable, and the particles do not scatter a beam of light passing through it. And the path of light is not visible. So when we pass the beam of light on it, it will not scatter the beam. Here are some examples of true solution. A solution of sugar in water is a solid in liquid solution, and in this solution sugar is solute and water is solvent. Second example, solution of iodine in alcohol. It is also known as tincture of iodine. Here iodine is a solid as the solute and alcohol is liquid as solvent. Third example, aerated drinks like soda water are gas in liquid solution. These contain carbon dioxide gas as solute and water as solvent. When air is a mixture of gas in gas. So air is a homogeneous mixture of number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities. Colloidal solution. It is a heterogeneous mixture of two or more substances. Example, mixture of starch in water, egg albumin in water, or milk, air containing dust, smoke. Colloidal solution is heterogeneous. Particles cannot be seen by naked eyes. Solute particles cannot be separated by filtration. Solute particles do not settle down and solution is stable. The particle scatter a beam of light passing through it and the path of light is visible in the solution. Let us know about some common examples of colloids. Colloids have disperse phase and dispersing medium. Say for example, when liquid is dispersed in gas, it is called aerosol. Example, fog, cloud, mist. When solid is dispersed in gas, it is also called aerosol. Example, smoke, automobile exhaust. When gas is dispersed in liquid, it is called foam. Example, shaving cream. When liquid is dispersed in liquid, it is called emulsion. Example, milk and face cream. When solid is dispersed in liquid, it is called sol. Example, milk of magnesia and mud. When gas is dispersed in solid, it is called foam. Example, foam, rubber sponge and pumice. When liquid is dispersed in solid, it is called gel. Example, jelly, cheese, butter. And when solid is dispersed in solid, it is called solid sol. Example, colored gemstones and milky glass. Suspension. A suspension is a heterogeneous mixture of two or more substances. Example, solution of sand in water, solution of chalk powder in water. Suspension is heterogeneous. The particles can be seen by the naked eye. Solute particles can be separated by filtration. Solute particles settle down and the solution is unstable. The particles of suspension scatter a beam of light passing through it and the path of light is visible in solution. This picture shows that solute particles of suspension can be separated by filtration and the solute particles settle down and this mixture is unstable. Let us know about the Tyndall effect. When a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of light becomes visible in the solution, and this effect is called Tyndall effect. Students, you might have seen when light enters a room through a small hole due to scattering of light by the dust and smoke particles. And this Tyndall effect can also be seen in a dense forest due to scattering of light by water droplets in the mist. Here in this picture, a scientist is showing how the particles or beam of light is visible. Saturated solution. A saturated solution is a solution which cannot dissolve any more of a solute at a given temperature. Solubility. Solubility of a substance is the amount of solute present in saturated solution of the substance. The solubility of different substances are different. The solubility of substances varies with the temperature. If the mixtures are heated, it dissolves some more of the solute. Unsaturated solution. It is a solution which can dissolve some more of the solute at a given temperature. Let us know more about the concentration of a solution. The concentration of a solution is the amount of solute present in a given amount of solvent or solution. So it can be amount of solute upon amount of solvent or amount of solute upon amount of solution. The concentration of solution can be expressed as mass by mass percentage or as mass by volume percentage. The formula for mass by mass percentage of solution is mass of solute upon mass of solution into 100, and the formula for mass by volume percentage of solution is mass of solute upon volume of solution into 100. So we can calculate the concentration of solution by these formulae. So in this part we have learned about pure substances and mixtures and their types, properties of two solutions, colloids and suspensions, and saturated solution and concentration of solution. Now in next part we will learn different methods of separation of mixtures.